So coming to the 52nd question of Zettili, we are given a state which is dependent on two variables. So two variable state function. So and we have to check if this state function is the eigenfunction of the operator a phi and b theta. That is our first question. And in the second question, we are supposed to see if the a phi and b theta are Hermitian operators. Then in the third question, we are asked to calculate the expectation value of operator a on the eigenfunction or on the wave function given. Alright, and at the end we are asked to calculate the commutator a phi and b theta. So that's it for the 52nd question. Let us start with the first part. And we are given phi equals to e to the power minus 3i phi cos theta. Now we apply a cap phi on our state vector, or let's say the wave function phi psi. We get partial differentiation with respect to phi e to the power minus 3i phi cos theta. So this will anyways come out. So we get cos theta partial differentiation with respect to phi minus 3i phi is 3i and cos theta e to the power minus 3i phi. So that is minus 3i psi. So this is some constant. When a is applied on the wave function psi, we get some constant into psi. So we can say that this operator a is eigenfunction of this wave function psi and gives us the eigenvalue minus 3i. Alright, similarly we do this for b theta, and we get b theta cap on psi partial differentiation with respect to theta e to the power minus 3i phi cos theta. So this will anyways come out because it's not dependent on theta e to the power minus 3i phi, and partial differentiation of cos theta gives us minus sin theta. So that is minus 3i phi sin theta. So it's theta. So this is no way equal to psi. So we say that cap is not we have to say that psi theta phi is not eigen function of operator b theta. Okay, and in the previous one we have psi theta phi is eigenfunction of a phi cap. Now we are done with our first question. Now let us move to the second question to see if the a phi and b theta are Hermitian operators. So one thing we can directly say from here, that the eigenvalues of a phi are complex, purely complex number. So if you remember the properties of a Hermitian operator, so Hermitian operator only gives real eigenvalues. Alright, so from this we can say that eigenvalues of a phi cap are purely imaginary, and that only happens when the operator is anti-Hermitian. So we get a phi is anti-Hermitian. Okay, now for b theta we have to check by our usual process. So by the usual process we have to see that the psi when applied on d by d theta, psi equals to d by d theta psi to psi. So we have to check this to state that b cap theta is a Hermitian operator. Now for LHS we get 0 to 2 pi, that is the limit of function theta, and we have psi as e to r minus 3i phi cap cos theta, and the partial derivative of psi gives us, okay, sorry, over here it will be plus because it's a bra, and minus 3i phi into minus sine theta d theta. Okay, so we get something as minus cos theta sine theta d theta 0 to 2 pi. For RHS we have 0 to 2 pi e to the r plus ei phi cap minus sine theta e to r minus 3i phi cap cos theta d theta. This both will reduce to e to the power 0, and that gives us 1. So we are finally left with integral 0 to 2 pi minus into cos theta sine theta d theta. So we see that LHS is equal to RHS, which implies B cap is Hermitian. Now note that in the previous one I have said that the eigenvalues of Hermitian operator are always real, but in the very first sub problem we have seen that b theta is not an eigenfunction. So let me be very clear that this operator b cap is not a eigenfunction but a Hermitian operator in general. I hope you get this idea of not being an Hermitian. Being an Hermitian operator doesn't imply that it is an eigenfunction for some state psi. Now let us go to the third question to evaluate the expression. We will first go with psi a cap into psi. So from over here, a cap psi, we get minus 3i into psi. So we have psi minus 3i into psi. we will take out this 3i outside. We write bra as plus 3i phi cap cos theta into e to power minus 3i phi cos theta, and finally we get minus 3i. This will reduce to e to the power 0, that is 1, and cos square theta. This is the final value that we are remained with. Now we have to calculate the expectation value of B operator. So from here we can see that when B operator is applied on psi, we are remained with e to the power minus 3i phi cap into sine theta. So instead of doing again what we have done earlier, I will directly put that what we have found earlier, that is minus e to the power minus 3i phi cap sine theta, and our bra vector is plus 3i phi cap cos theta e to the power minus 3i phi cap sine theta, and finally we are having minus sine theta cos theta. So this is the result we are left with, and at the end we are asked to find the commutator a phi and b theta. So for the commutator, I am assuming the book has asked us to take test function as the given wave function. So a cap b cap is nothing but ab minus ba. Now applying that on a test function, we have a cap b cap minus b cap a cap on test function ab minus ba. We are having now d by d phi d by d theta into psi minus d by d theta into d by d phi psi. So first we will in this bracket, first we will have partial differentiation with respect to theta, and then partial differentiation with respect to phi. So substituting the value of psi and doing the partial differentiation with respect to theta and phi, and in this bracket with respect to phi and theta, we have d by d phi minus e to the power minus 3i phi cap sine theta minus d by d theta minus 3i e to the power minus 3i phi cap cos theta minus 3i e to the power minus 3i phi cap sine theta minus 3i minus e to the power minus 3i phi sine theta. So this will reduce, and we have seen that this will go off and we are reduced with 0. So saying that a phi and b theta and applied on a test function psi, we are reduced with 0 psi. So the value of a phi b theta commutator is nothing but 0. So that's it for this particular solution of question 52.